Hi students, I am Professor Avis Ahmed Hussaini, working as Assistant Professor in Mechanical Engineering Department at Sharad Institute of Technology, College of Engineering, Yadra. Students, in this video we will discuss various methods of producing cooling or refrigeration effect. So let us start with the content of this particular video. So there are so many methods of the producing refrigeration or cooling effect. First is dry ice refrigeration, second one evaporative refrigeration system, third one is thermo-electric refrigeration, fourth is vapor compression refrigeration, fifth is vapor absorption refrigeration, sixth is liquid gas refrigeration system, and seventh one is Vertex tube refrigeration system. So let us start with the first dry ice refrigeration system. So solid carbon dioxide, that is CO2, is act as a dry ice. So solid carbon dioxide is called as a dry ice, and it has a peculiar characteristics that it changes from the solid state to vapor state without getting converted into intermediate liquid state, that is you can say it as a sublimation. Due to the changes of the state, it absorbs the heat equivalent to enthalpy of vaporization. The sublimation temperature of the dry ice at atmospheric pressure is near about minus 78 degrees Celsius. The dry ice is used to preserve the food stuff during the transportation. So the best example of that dry ice is that in transportation trucks, where we have to preserve that food or any kind of the milk atoms, some kind of the meat for a longer duration of time. Nowadays, it is universally used to preserve the food in the air transportation. So this is the most important concept in the cold chain application. So in cold chain application, we have to supply that commodities like fruits, vegetables, meat, milk from one position to long distance. At that time, that particular dry ice concept will help to preserve the food for a longer duration of the time. So the dry ice slabs are usually packed into the frozen food or cartons on either side or on the top of the food packages. The dry ice absorb the heat from that food stuff and preserve them in the frozen state. So this is the basic and simple working of that dry ice. Mostly for that meat preservation, fish preservation, or some kind of the fruit preservation, that particular dry ice refrigeration is used in cold chain application in transportation vehicle. The second one and important one is that evaporative refrigeration technique. This is old technique. Evaporative refrigeration makes use of the principle that when a liquid evaporates, it absorbs heat equivalent to its latent heat of the vaporization from the surroundings, thereby cooling it. The cooling of water in the earthen pitcher is the best example. The water coming out from that porous of the pitcher evaporates when it comes in contact with that dry air, thereby cooling the water in the pitcher. So students, that zero energy cooling chamber used for the application of preserving or storing the agricultural product like milk, fruits, vegetables for a longer duration of time, that evaporative cooling technique is mostly used, and this is a very old and economical technique where we never need the use of that electricity. When a drop of the spirit is put on the palm of hand, it evaporates, producing the cooling effect. This is the best example. So the evaporation cooling may be defined as the adiabatic transfer of the heat from the air to water. Evaporation cooling may be defined as the adiabatic transfer of the heat from the air to water. It is utilized in the cooling tower where condenser water is cooled by spraying it from a top and forcing a current of the air from below. Another application of that evaporative cooling is the type of the condenser. Yet another application is desert coolers, room coolers, dry air is passed through the wet pads. Due to evaporation, air gets cooled. The principle is also utilized in making artificial snow. So students, as far as that refrigeration, economical refrigeration is to be concerned, that evaporative refrigeration is good than other method because the overall cost of this method of the implementation is less for a small kind of the application like room cooling, desert coolings, etc. So the third most important way of the producing the cooling of the refrigeration process is that thermo-electric refrigeration. So here you will get idea about the parts. So here you can say it as one kind of the junction is formed here. So thermoelectric elements are used in the middle section of the two junction. Out of them, the one junction is that cold, so it absorbs the heat, and second one is that hot junction which can reject the heat. So the electric conductors or the insulator is placed so in between that particular two junction. So whatever the thermoelectric element is preferred for that thermoelectric refrigeration, it must be that electrical conductor. So in case of the thermoelectric refrigeration type, employs Peltier effect when two dissimilar metals are joined on either end and a direct current is circulated through it. One junction get cooled while the other get heated. So this is the basic working of that Peltier effect. So students, that antimony and bismuth are commonly used metal as a electrochemically deposit in their polarities. If the cold end is placed in a closed space, it gets cooled. If the magnitude of the current is increases and the series of such strips are pressed together, a good cooling effect can be produced. So it is very simple technique used for a small application like that water cooling as well as that small area or that space cooling purpose. So this totally that thermoelectric refrigeration is works on that Peltier effect. So student, the fourth important one is that steam jet refrigeration. Here we will get n number of the components like that flash chamber is there, then condenser is there, ejector is there, then most important is that steam nozzle is there, control valve is there, boiler is there for producing that steam, continuously water circulation is there along with that particular pump arrangement, makeup water is required continuously in the flash chamber, and this is the most important kind of the concept used in that commercial application. So the principle of the steam jet refrigeration is that the boiling point of the water can be reduced by reducing the pressure. So this is a basic working principle of the steam jet refrigeration. And keep in mind that for producing of the steam we must need that particular boiler. So the boiler is a device which is mainly used to produce a high pressurized steam. At standard atmospheric pressure, the boiling point of the water is near about 100 degrees centigrade, as we know that. If the atmospheric pressure is lowered, the boiling point is considerably reduced. So this is a basic science behind it. For example, at the pressure of the 6.5 centimeter of the water, the boiling point of the water is considerably reduced to 5 centimeter of the water. Its boiling point is reduced to 6 degrees Celsius. Due to the evaporation of the water at a low temperature, the remaining water in the flash chamber get cooled, which is circulated through the refrigerated space, and warm water receives from it to spread in the flash chamber. So a makeup water connection is provided continuously in the flash chamber to make good any water lost in the evaporation. The steam in the supply to the nozzle from the boiler, the condenser condenses the steam and water vapor received from a flash chamber. The condensate from the condenser is taken back to the boiler. So students, the basic science behind it is that evaporation of the water at a low temperature, the remaining water in the flash chamber get cooled, which is circulated to the refrigerated space, and warm water received from it spread in the flash chamber. So this is a basic principle is that Steam jet refrigeration is the boiling point of the water can be reduced by reducing the pressure. So the fifth important one is that vapor compression refrigeration system. As we know that the basic components of that vapor compression refrigeration system is that particular compressor, condenser, expansion valve, evaporator. So in case of the compressor, the wet vapor refrigerant enters, it gets compressed at a high pressure. Generally the compressor is used as a hermetically or semi-hermetically sealed, and that high pressure high temperature vapor refrigerant enters in the condenser. So in condenser, the latent heat of condensation takes place and phase change takes place from vapor to liquid, and liquid refrigerant enters in that expansion valve where the throttling action is carried out, and high pressure high temperature liquid refrigerant get converted into low pressure low temperature liquid refrigerant. And the same liquid refrigerant enters in the evaporator. In evaporator, the latent heat of absorption takes place and phase change takes place from the liquid to vapor, and here you will get cooling effect. That evaporator is placed in the application area where we get that cooling effect, and the same refrigerant in the vapor form is circulated throughout the cycle in this particular process. So the next most important is that vapor absorption refrigeration system. Most of the component of that vapor absorption refrigeration system is same as that of the vapor compression refrigeration system, but only the main difference is that compressor is replaced by that generator, absorber, or that pump arrangement in case of the vapor absorption refrigeration system. So students, whatever the refrigerant mostly used in case of the vapor absorption refrigeration system is ammonia. So that ammonia continuously changes its phase from that vapor to liquid or from that liquid to vapor. So from evaporator, that wet refrigerant enters in the absorber where it get absorbed by that water and weak solution, whatever is available, it get converted into that strong solution, and that particular strong solution of that aqua ammonia enters in the generator through the pump arrangement. So in generator, external heat is provided for heating that particular whatever the mixture of that strong solution is there which is available at that generator, and finally we will get the strong or high pressure vapor refrigerant of that ammonia, and it enters in the condenser. And if suppose some kind of the water particles of that ammonia remains, so it enters in the absorber through that, or you can say it as a weak solution enters in that absorber through this particular non-return valve. And that high pressure high temperature ammonia vapor refrigerant enters in the condenser where latent heat of the condensation takes place and phase change takes place from that vapor to liquid, and that liquid refrigerant enters in the expansion valve through the receiver. In expansion valve, the pressure and temperature of that liquid refrigerant goes and reduces, and the same refrigerant enters in the evaporator. In evaporator, latent heat of the absorption takes place and phase change takes place from the liquid to vapor, and this cycle is continuously repeat itself. So this is all about vapor absorption refrigeration system. So students, this is that Vertex tube system of the refrigeration. Here you will get one long tube which is separated by some kind of the throttling area, and that compressed air enters from this particular location, and from this throttling area it continuously separate out or split up, and here you will get both different location in each extreme position of that tube. Here you will get that some hot exhaust air, and here you will get some kind of the cooled air comes out. So in case of the Vertex tube is a simple straight piece of a tube into which the compressed air flows tangentially and is so throttle that the central core of the stream can be separated from the peripheral flow. The central core of the air is separated either by uniflow or by counterflow method. So here you will get some kind of the counterflow elements in order to produce that Vertex. The central core of this stream is cold as compared with the hot gases at the periphery.